Saxon Algebra 1, Lesson 37. You guys, last time I was talking about, it's the movie, right? With Jim Halpert, aka John Krasinski from The Office, and how he played the nerdy CIA guy who became an action hero. Jack Ryan is the name of it. But now I can't remember why I was talking about it. But in any case, at least I remembered Jack Ryan. I thought of it like 5 seconds after I finished the last video. So I wrote that on the page so I'd remember to tell you that I remembered, but now I don't remember why I remembered. Oh my gosh. But here's the thing. I never forget what I need to tell you about for algebra. And today we're talking about a subject that most students find kind of fun and relaxing. And they're inequalities. Okay, just to go back to basics. This is a symbol that means equals, right? You see it all the time. It means two things are the same value, right? We have another way of talking about equality and to say two things are not equal, right? We just draw the little line, kind of like a stop sign, you know, this kind of a thing. That's not a stop sign, but you know, a lot of traffic signs use that symbol. So we can use this as well. We don't use this one very often. Every once in a while, there will be a use for it, but not that often. What is more common is when we use what we call inequalities. And that is to say, we know these things aren't equal, but we can say something about them. This is less than, right? We read this as 4 is less than 5. And then the other possibility is like this, greater than, right? So in the cases when things are not equal, we have these two signs that help us talk about how they're not equal. So we call these inequalities. We can also think about greater than and less than in the context of a number line. A number line goes to infinity, and it's the arrangement of all numbers, whole numbers, integers, the nice simple ones, but also fractions and decimals and percents can all be put on a number line. We tend to center it and look at 0, which is a fun place to look because there's symmetry in the number line here, right? We can go 1, minus 1, 2, minus 2. Minus 2. That's nice. It's not necessary to look at this section, but we tend to like to look right around 0 because it looks cute there. It's very pleasing. All right, and a lot of the problems we do have relatively small numbers, so we can find them on this part of the number line. But we can kind of scan up and down anywhere we want. Remember that the hash marks that we make represent where exactly like 1.00000000000 is. But, you know, we can go to 1.00001, 1.00002. You know what I'm saying? There's an infinite number of little decimal and fraction numbers between 1 and 2 in this example that are represented here. So this, each hash mark represents the exact value, but there are an infinite number of tiny values in between. Okay, as we move this way down the number line, the numbers become, we say smaller, but mathematically that's not correct. We say they become lesser, and then as we go this way, they become greater. Those are the appropriate math words for how the values of the numbers change as we move in that direction, all right? So less than and greater than are the proper mathematical terms that we want to talk about the value, okay, of the numbers. So let's look at what these problems look like. I'm having a problem with my 3's and my 2's, aren't I? 37.1. Draw a number line and graph the solution of, okay, So what this means is we want to draw a picture with a number line showing all the solutions for this inequality. Now, unlike our equations where we have only one solution that makes it true, with these inequalities, we have a whole bunch of them. So that's why we want to use the number line, because it's a great way to show a whole bunch of numbers. So this is the way we would show that. I'm going to draw the number line, and I'm not even going to put in this much detail. I'm just going to put in 2. That's the number that we're interested in because that's the number in the inequality. And we want to say that we want the values for x that are greater than 2. We want to go this way, right? This inequality says that we only want the ones greater than 2. So that means we cannot include 2.00000000, right? It has to be greater than that. But there's lots of numbers between 2 and 3 that are greater than 2. So this is how we indicate that. We draw the circle and we point an arrow this way. And this symbolic notation says not that exactly, but every number greater. That's what this notation describes. And that's what we want for our answer, right? It's got to be greater than 2. So not 2 exactly, but every number greater than that. That's how we show it with the open circle and the arrow going that way. Okay, let me squeeze another one in down here, 37.2. There are only a total of 3 in this lesson. Draw a number line and graph the solution of x. Okay, x is less than 2, but as you know, what this means is less than or equal to. It's 2 symbols, this one and this one, rolled into one, right? So we've got the inequality and then we've got that, and it makes it look like a little equal sign down there. So when we draw this graph, again, all I need to draw is the 2. Now, instead of circling the 2, which said don't include 2, this time we make a solid dot. And this time we're going less than, so the arrow needs to point this way, down toward the lesser side of the number line. So this solid dot means include 2.0000000000 and off the page, right? We want to include that value in our answer. So a solid dot is what we use when we have an equal to. An open circle is what we use when we have just the inequality. One more. And in this one, John gives us the picture and he asks us to write the inequality. So let me draw you the picture. I'm going to draw you a shorthand version of the picture. We're at -3 and there's an open circle and it goes this way. So that would be x is less than 3. Should we include 3 in our solution? No, because it's an open circle. So this is, oh, I'm sorry, it should be -3. I just spaced on that. But the main thing is that because this is an open circle, we want to have just the inequality and not the underline. We would put the underline only if that was colored in. Final answer, yay. We're going to add on to this. We're going to have a lot of fun with this. Again, these problems, these inequalities, tend to be A, easy to understand, and B, simple to calculate. So most students find them pretty fun, pretty manageable. So, I mean, yay for John showing us a good time. All right, I'll see you next time for 38.